Mechanical drawing, sketch your ideal blueprint. Hello, everyone. Welcome to the micro class on mechanical drawing and tolerance fit. In engineering technology, people often use various types of drawings, such as mechanical drawings and architectural drawings. These drawings are created using different projection methods. Mechanical drawings are created using orthographic projection. The task for this lesson is to master the basic knowledge of projection, the establishment of the projection system, and the formation of the three views. First, let's take a look at the task drawing for this lesson. Step 1. Read the title block. The name of the part is composite part. Its drawing scale is 1:1. And its material is ZL104. Step 2. Read the views. First, let's analyze the expression scheme of the task drawing. The part drawing uses three views for expression: one front view, one left view, and one top view, or using basic views. The front view reflects the main features of the composite part. The left view and top view supplement the shapes and structures not clearly expressed in the front view. Next is the shape analysis. On this composite part, there is a slot on the left side with a length of 18, width of 15, and height of 18. On the right side, there is a protrusion with a length of 18, width of 48, and height of 48. Step 3. Read the dimensioning. From the drawing, we can read the overall dimensions of the part. It has a length of 72, a width of 48, and a height of 48. Step 4. Read the technical requirements. 1. Read the dimensional tolerance. The overall length of the base plate is 72. The upper limit deviation is 0. The lower limit deviation is negative 0.05. The width of the base plate is 48. The upper limit deviation is positive 0.034. The lower limit deviation is negative 0.009. 2. Read the form and position tolerance, none. 3. Read the surface roughness, none. Next, we will focus on the study of orthographic projection and the formation of the three views. In life, when objects are illuminated by sunlight or lamplight, they cast shadows upon the ground or walls. There exists a one-to-one correspondence between the shape of the shadow and the object itself. This phenomenon is referred to as projection. To achieve projection, three essential elements are required: the object, the projection lines, and the projection surface. The projection lines pass through the object and cast onto the selected surface, and then we obtain the figure on that surface. This is referred to as the projection method. Projection methods are categorized into central projection and parallel projection, based on whether the projection lines are parallel or not. The projection method where the projection lines converge at a single point is called central projection, and the projection method where the projection lines are parallel to each other is referred to as parallel projection. Parallel projection can be further divided into orthographic projection and oblique projection, based on the different positions of the projection lines relative to the projection surface. Engineering drawings are typically rendered using the orthographic projection method. This is because, in orthographic projection, the projection lines are perpendicular to the projection plane. The size of the projection is independent of the object's position, offering superior measurability. Additionally, orthographic projection possesses fundamental properties such as authenticity, convergence, and contraction. It can accurately and completely express the shape and structure of a form. Moreover, due to its simplicity in drafting, it is widely applied in engineering drawings. When creating mechanical drawings, the object is placed between the projection plane and the observer. It is commonly assumed that the lines of sight from the observer are a set of parallel lines that are also perpendicular to the projection plane. Depict the outline and shape of the observed object graphically on the projection plane. Then, the orthographic projection obtained on the projection plane is called a view. Let's now look at the projections of three objects with different shapes. It can be seen from the figure that the shapes of the three objects are different. So what about their projections? Let's take a look. From the animation, it can be seen that if single view projection is used, the spatial shape of the object cannot be determined. If two view projection is used, can the spatial shape of the object be determined? Let's take a look. As observed from the animation, even with two plane projection, the spatial shape of the object still cannot be determined. So what about using three view projection? From the animation, it can be seen that three view projection can determine the spatial shape of the object. This indicates that a single projection plane cannot fully express the shape and size of an object. Therefore, in mechanical drawings, multi-view projection is used to express the shape and size of objects. Among them, the three views are the most commonly used. The three views are orthographic engineering drawings that can correctly reflect the length, width, and height dimensions of an object. It includes the three basic views: the front view, the top view, and the left view. First, let's talk about the three projection plane system. The system composed of three mutually perpendicular projection planes is called the three projection plane system. The three mutually perpendicular projection planes divide the space into 8 regions. The national standard stipulates that mechanical drawings use the first angle projection method. The third angle projection method is allowed only when necessary. Therefore, we mainly discuss the projection of objects in the first angle. In the three projection plane system, the projection plane facing the observer is called the frontal projection plane. It is simply referred to as the front plane and is denoted by the letter V. The projection plane in the horizontal position is called the horizontal projection plane. It is simply referred to as the horizontal plane and is denoted by the letter H. The side-standing projection plane is called the profile projection plane, which is simply referred to as the side plane and is denoted by the letter W. The intersection lines of each pair of the three projection planes, namely OX, OY, and OZ, form the projection axes. The intersection point of the three projection axes, O, is called the origin. Next, let's discuss the formation of the three views. Place the object into the three projection plane system, project the object onto each of the three projection planes respectively. Then we will obtain three projections. When the object is projected from front to back onto the frontal projection plane, V-plane, the resulting projection is called the front view. When the object is projected from top to bottom onto the horizontal projection plane, H-plane, the resulting projection is called the top view. When the object is projected from left to right onto the profile projection plane, W-plan, the resulting projection is called the left view. In order to draw the three views on the same sheet of paper, the national standard stipulates that the horizontal plane should be rotated downward by 90 degrees, while the front plane remains stationary. The side plane should be rotated to the right rear by 90 degrees. In this process, the OY axis is divided into two parts. When rotating with the H-plane, it is denoted as OYH. When rotating with the W-plane, it is denoted as OYW. In this way, the front view, top view, and left view can be obtained on the same plane. Based on the relative positions and the shape after unfolding of the three projection planes, the positional relationship of the three views is defined with the front view as the reference. The top view is directly below the front view. The left view is directly to the right of the front view. Since the size of the projection plane is irrelevant to the views, in order to simplify the drawing process, when drawing the three views, there is no need to draw the boundaries of the projection planes and the projection axes. And the distance between the views can be determined according to the specific situation. Through this learning session, we have understood the principles of orthographic projection and the formation of the three views. We have learned that to accurately express the structural shape and size of an object, it is necessary to use the three views. That's all for this lesson. Welcome to continue following our mechanical drawing and tolerance micro class. See you next time.